Hey guys, how's it going? Well, it's about midweek here at Baggett Corner, and we're going to try to fit a little bit of work in midweek. Usually I don't do anything till maybe weekend or Friday, but I got a couple hours on my hands today, so let's see what we can do. So you're looking at this stuff. That is the pulley that the fan runs on. This fan attaches here. See that? The back you got to touch. There we go. Back you right out. So this pulley is attached to the fan in this way, like so. And of course, you got this pulley on the top, you got another pulley at the bottom on the crankshaft, and you got a belt in between them. And that belt spins that pulley, turns that fan, and that fan, of course, blows air through the radiator. Blows or sucks, I'm not sure which. Depends which way that's turning, I guess, huh? And don't feel like somebody bleep bloop it down in the comments there which way it turns. Let me know. Otherwise, I'll figure it out on my own. So anyway, here we are. This is one of the first repairs on the engine. Not one of the first, but you know, one of the things we need to overcome, because if this is not in good shape, the belt's going to fly off all the time. We already, which you're going to see in another video, we already have a new pulley for the crankshaft, because that one is just weeble wobbling all over the place. And that can't work. So that's moving all over the place. This one's moving all over the place. All that's going to happen is the belt's going to fly off all the time, and we're not going to get enough cooling. So this arm, how about I just walk you over for a second? You can see where this goes, okay? Just hold on. Ignore the mess. You know how it goes. This dude goes here, basically. Can you see that? In the midst of all my junk, I'm up here. That mounts on there, and it just adjusts this way or that way for your belt tension. Clear as mud? All right, good. Put you guys back where you belong here, right on the bench. On the bench with me. Okay, so here's some stuff. So I got looking at this, and I have taken the liberty of cleaning this up a lot for you, because it was a greasy mess. There was grease everywhere, so I cleaned it all up. And can you see? So we got lots of movement this way. Okay, we also got lots of movement this way. Can you pick that up? There you go. You can see it. So there shouldn't be that much. There should be maybe BB. It should be 2,000, maybe 2,000 wear, or sorry, not wear, but room for this, for the grease to go from this grease zerk into the bearings. And the grease also helps keep it kind of snug as well. But you can't rely on, you know, grease to take up that amount of room. What's also missing here is there's supposed to be a washer, a felt washer. When I pull this apart, you guys are going to get a little bit of a look at that, but there should be a felt washer in there to stop this movement. You know, a little bit is okay. A wee bit of hunting back and forth is okay. You can't have that much. So let's take this apart, and you can see how this all works, okay? The castellated nut here. You got this guy, which threads out. So that's your adjuster arm, or mount as well, I guess you could call it. Comes off. This guy, let's give that a whack. Knock that over there. So a felt washer goes in this dude here, right there, which sets up against this bushing here. Stops your grease from getting out, basically, is what it's doing, and helps to lubricate a little bit. So main thing is it stops the grease from getting out. So as you can see, I mean, look at the room there. Look at the play. Can you guys see that? Man, tons. So that comes out. So we got a bit of wear already on this shaft. In the middle, basically nothing. So in the middle, you got 0.625, 0.624, somewhere in there. So you got 5/8. Right? Is that what that is? Yeah, it's 5/8. 0.625. On the ends, you've got 0.621 on the ends. So you got 4 thou wear overall. It would be a big deal maybe if we were ordering some bushings from somebody and they came in a stock size. But, you know, we're going to make the bushings ourselves here because you make what you can, and what you can't, you buy, right? So anyway, so we got 4 thou wear on the ends. Like I say, nothing in the middle. Now, if we look at these bushings, can you guys see, man, can you see that? Can you see the grooves in there? There's a ton of wear. Can you hold you up against my mic? You can hear it. I mean, one side's good. Well, not good, but one side's not as bad. This side's worse. So basically, this side here would have been the one that had the most pressure of the belt pulling down. So naturally, you're going to get the most wear. What do we got? We got 0.656 over on this end. We got 0.65, almost 0.660. So let's just say 0.660. So what does that leave us? That leaves us 39 thou of wear. Obviously, that's not going to cut it, right? We want to be down somewhere around 2 thou. Should I say maybe 3 thou on the real wide end of loose fitment. Obviously, you know, anything more that 30. What did I say? It's almost 40 thou wear. Anyway, so what we're going to do is we're going to knock this bushing out first. We're going to take some measures, and we're going to make a bushing, at least one for sure. And then if it works out nice, we'll make another one. I think I covered it all with you guys on that. So we're going to make a bushing that's going to fit up to this end here, which is 0.621. So we're going to make the inner diameter of that bushing 0.619, 0.620, something like that. That makes sense. Sorry, vice versa. You know what I'm saying, right? 0.621. So we're going to make the ID 0.623. Clear? Sorry for messing up there. Didn't have it quite straight in my head yet, but anyway, 2 thou. We're going to go aim for about 2 thou difference. So not an interference fit, not a tight fit, just not a sloppy fit. So what do we got? We got what are we going to make our bushing out of? We're going to make our bushing out of, and I have been sort of warned against this, and I don't really care. I'm going to do it anyway because I want to, because I can. I've got Delrin rod. So I don't know if you guys know what Delrin is, but it's used often for bearings, gears, inside engines, and it's a self-lubricating type of a polymer, I guess. It's type of a plastic, self-lubricating. It's good for about 250 degrees on the upper end of the temperature scale. A bronze, like a sintered bushing, would be good for probably double that, maybe 500 degrees, somewhere in there. Now, I don't think there's any way that we're going to get to those temperatures, especially if this is basically a self-lubricating bushing, and we're going to have some grease in there. So, you know, without a lot of resistance, a lot of resistance, basically, a lot of force kind of holding it. What's the word? You guys know the word. Stick in the comments. Help me out here. Without a lot of pressure against it, it's not going to develop heat, and I don't think it's going to develop heat anyway, especially with some oil or some grease in there. So this is the smallest piece I had. I wish I had it a little bit smaller. I'm going to have to take a fair amount off the outside. So you can see, you know, we're going to take, well, some. And we have to make, looks like we have to have a little bit of a shoulder there. I'm going to have to knock it out, measure the full the full width, the inner diameter of the bushing, the outer diameter of the bushing, because we need a slight interference fit. After we've got that interference fit, I may have to ream it to fit, because once you press something in with a bit of interference, it tends to squeeze in on the inside a little bit, and you have to ream it. Basically, you have to get one of your reams out and make it to size. So that's how that works. You know, that's just one of those things. So yeah, listen, I know that I can buy those bushings, no problem. I know I can buy them. I may even, if I'm not satisfied with this, I may go check locally and see if I can get a sintered bushing. It doesn't have to be that exact. It may, I don't even know if it needs that shoulder. Realistically, if it didn't have that shoulder, we could make a washer out of the Delrin to substitute for that shoulder on either side. So it doesn't have to be that shoulder. I could probably find a sintered bronze bushing that'll fit in that ID nicely, and then maybe I'd have to ream it to the correct size for that shaft. How's that? Way too much info? Probably, right? Yeah. Anything I didn't cover? If there's anything I didn't cover, stick it down in the comments, and I'll answer you after I put the video up. Basically, I'll answer you after the fact, right? Yeah. So anyway, I was kind of warned against it, but I'm like, you know, whatever. I'm going to try it out and see how it goes. And people say, well, brass is the way to go, bronze is the way to go, blah blah blah. I'm like, well, I don't know. I'm willing to try something that they never had back then in 1920 odd, whatever. They didn't have this, and maybe if they had it, maybe they would have used it. Maybe they wouldn't have used it. Maybe they still, because there's still plenty of purposes, plenty of uses for brass and bronze now, and they're used still today. So let's get you guys over to the. We're not going to go lathe there. We're going to knock this bushing out. I'll show you how to do that, and then we're going to go to lathe. So hold on a second. Okay, guys. We are back. That's how we want to knock out. The bushing doesn't go all the way through, and it doesn't butt up inside. There's that gap in there, which, well, that's where the grease, is that where the grease? No, that's not where the grease goes. But anyway, there's a gap inside between the two. Grease often does sit in there and just kind of moves around. What I noticed on these bushings as well is often when you have a bushing like this, like a wrist pin, for instance, you're going to have a groove cut into that. And the grease or oil is going to travel down that groove and just help to kind of smear it around there. And I don't think we're going to have to do that with the Delrin. But if I just change my mind and I go to bronze, then I'm going to end up filing a groove. And what you do is you take a 3-sided file and you just stick it in there on edge, and you see it? You just cut yourself a groove. I don't have a 3-sided file in my hand, but that's all you do. You just cut yourself a groove in there. That's how you do it. So I'm going to set this, we want to get this side out. So I'm going to set this down here. Not snug, because we want it to come out, obviously. And just kind of nicely supported, right? We don't want to break anything. Take the biggest punch you can fit in there, get it on a shoulder, and just tap, tap, tap. And then see if we're moving. And we're not yet moving. Keep going. Side to side, back and forth. Nope. If you hear a sound difference, something happened. Either something broke or something moved. And nothing broke, but that moved. So we're good. I'm going to keep on going. Back and forth, like I say. Because I don't want to caulk it in there sideways and screw up that bore at all. That's moving out pretty good. And we're just going to keep, I'm going to take you guys and just shut you off, and you go get yourself a beverage if you want to. I'm going to keep going on that. And like I say, just be cautious. I mean, you could even put a rag down here, which, you know, you can take a pair of my greasy briefs and stick that on there. You so desire. And maybe we won't. What the heck. just to protect the face, but I think it's supporting it pretty nice. So anyway, I'll shut you off, pull that out, and we'll take some measurements. All right, so we knocked that out. Go. So interesting. I mean, I would say that that wear has been over its entire life. So, I mean, you got 100 years of a bushing being in there, and that's the first time it's been out. When you think back on stuff like this, right, where first time in, well, first time possibly out of here in 100 years. Kind of crazy when you think about it, right? Measured them up. We got 0.809 and 0.808. 0.809 obviously is this guy. That gives you a 1 thou interference fit. So not super tight, like like a thou and a half, or 2 thou would be extreme. But you get a 1 thou interference, so that's going to go in there. Nice. And you know what? It's captured anyway. It's captured here with the nut and which way? Sorry, this way. It's captured. Can't get out. It's also captured. Is it captured the other way? Yes. It's captured the other way by that bolt, so it can't ride out. So the thou interference is fine. So what I do usually is I take myself a book. You might take yourself a book like that. Bag of Corner, Thoughts and Sketches. You can buy them on Amazon. Put your thoughts, sketch stuff, write stuff down, you know. That's how I do it. How much am I selling these for? Probably not enough. I think they're like $5 or something on Amazon. If you want a book. Moving along. What I usually do before I go to the lathe is I sketch out all my dimensions. I make a little drawing of the piece I'm making. I, make a little blueprint basically of the part I'm making, and then I take measures along the way, kind of a thing, while I'm making it on the lathe. So I don't know. That's how I do it. How you do it. If you want to keep it all in your memory, that's fine. But even if I just wrote down dimensions. For me, that's not enough. I actually need to draw the part and then write the dimensions where they are on the part, like a blueprint. So I'm going to do that, and then we're going to go over the lathe. Have a look. The worst thing is to go past it and you've just wasted that material, so we don't want to do that. So we are coming in close now, so we're going to make some easy light passes. Just with the power feed. Again, check as you go. When you're getting close, just keep checking. There's no rush. You're doing this for fun, right? That's pretty close, guys. Your parting tool sharp. Doesn't have to be all that sharp on this. We need to part at this position. We still have that shoulder. Another Friday night.
Friday night.
My dad's here again, helping out with the project, with the truck. And we're kind of just scattered all over the place. I'm still working on the fan pulley. Gonna finish that up tonight. We made one bushing, gonna make another bushing here. He's working on some other stuff. He's working on the crank handle, cleaning up that fan. He's gonna put some paint on. So So we got the crank handle pulled out. We got to pull that bushing out yet, out of there. Got my shop Crocs on, you can see that. And yeah, shop Crocs. And so that got pulled out pretty good. He's cleaning that up. He's gonna put some paint on there. He brought out some burgers and some Coke, and last time he brought the rum. Did a choice of paints. Anyway, so here's the crank handle, all good. We got the new crank handle bushing. What did I say that difference in size was, Dad?
I can't remember now.
I can't remember. It was, it was 30 thou, something like that. 30 thou wear on the one that's in the car, the truck right now. 30 thou wear over this one, which, so this is a 3/4 inch shaft, and this is 3/4 plus, I think it was about 3 or 4 thou. So that's a really nice fit. I only got the one hand, sorry. There's the new spring, which I've already lost the old spring, but the old spring was only about half as much as that. And a pin. All this had to be, well, we had to use the heat wrench to get that guy off, but now it goes off and on really nice, real slick. Clean that up too. And yeah, reuse that pin. And he'll put some paint on his crank. And that's another Friday night. Another Saturday night. Who sings that, Dad? And I ain't got no, you know, you've lost it. All right. All right, guys. There's our fan pulley. We got one in one side already. Here's the other Delrin bushing. A bit of a shoulder on it. Should be a nice snug fit there. Just drive that in. Good. That's in. So the reason I put this in before I get it to final size is that interference fit is going to crush that down a little bit. So you would end up having to ream it twice. So I got my reamer set up for a little tighter than I would want because I can always go bigger, but I can't go smaller. I just got it on a hand T here. So run it through. Reamer goes one way. Can't really get a hold on that. But just turn that. You can power ream it if you want, but I think going by hand is good. Get through there. And same thing when you return it back out, where you just drop it through the hole. As you come clockwise, not counterclockwise. It probably doesn't make a big difference in Delrin because I don't think it's going to dull the blades. But anyway, let's see what we got for a fit now. Bit bigger. It's really close. So this is an adjustable reamer. So down here, when it's set way down here, it's at its level limit. Like an adjustable reamer will have a low to a high. So this one is excuse me, 19 30 seconds to 21 30 seconds. So we're going to just adjust this a little higher up the shaft, which is going to make these cutters kind of kick out. I don't know if you guys have ever seen one, but I think I have a video at some point where it talks about reamers, adjustable reamers, and all that kind of stuff, and fine or precision cutting tools. So we're just going to move that up a little bit and just take a little bit more ream. And you guys already seen me ream that, so you don't need to see it twice. So I'll do that one more time, and we'll see if we can get it so that we got about, oh, I don't know, 2.5 to 3 thou clearance for this shaft. Okay, guys, just the final run through with the ream. I actually just adjusted it about I don't know, maybe a 32nd of a turn, just to make it slightly larger. I was at about maybe may have been a thou play, 3/4 of a thou play. Wasn't much. It was just enough where I could feel a little resistance, and I didn't really want any resistance there. So let's get that out. Back the same way, you go in. Okay, let's check for fit. There you go. There is not really any discernible play, and there is no resistance. So that's it. We're going to go with these 2 Delrin bushings. See how it works. If it doesn't work, well, we can always change out to bronze. All right, my dad talked me into getting a sleeve out tonight, so here we go. We're gonna give it a try. He just wouldn't leave it alone. So obviously we'd prefer to press it, and we could probably press it through, but we've got the cap off. This is kind of like, it's almost like a bearing and cap kind of affair. This piece here is the same is with this. Now it's not cast, it's actually steel, so I'm not really too concerned that we're going to snap anything. At least I don't think it's cast.
Part of the oil pan.
Unless it's brazed on. I'm not too sure. It might be just on here, riveted here. Hard to say. But I don't know. I think it's going to move. Anyway, so that would be like, the bottom would be like your rod, and this would be like your rod cap kind of affair, and this clamps down, holds the engine in place on top of here. So we're going to try to keep moving that through. Give it lots of lube, and if not, we'll have to give it the flame wrench, I think, but I think it's probably going to go.
All right.
What's that?
So much for that idea.
Yeah.
Oh, so it's just, yeah, it's a split.
It's got a split in it.
So
It's like a split pin. Kind of tightens itself in. Well, there you go. I guess we got it out. So I guess we got to keep on rolling with this.
Night's still young.
It's still young, yeah. It's only about 10 o'clock. Yeah. Well, I didn't push record. Stupid me. Anyway, we slid the new one in here. Just had a rod with a nut on the other side, and just tightened this one, just pulled it back in there. And it moved in real easy. Just use a little hand pliers, really, it slid in really nice. So that's all there was to that. That was pretty darn simple. And if you need to know how, just bloop it in the comments down below, and I'll tell you how simple it was. Actually, it was really, really simple. Nothing to that at all. It was maybe, I don't know, half a thou, 1 thou interference. It's actually a huge roll pin is what it is. So no big deal. Once it starts, it just slides right in. All right, we're just waiting for the fan to dry, and that's probably going to take a while. I think Dad put quite a few coats of paint on there, so that's okay. Anyway, let's get you a light. Get me a light anyway, so I can see. Whew, there it goes. This is ready to go. Made a gasket for that. So the fan goes on top of here, top of this gasket. That gasket is, so what happens is the grease goes in here, fills up this area, runs into the bushing all through there, and that's it. So anyway, I left this with a little bit of play. You see that? Oh, I'm one-handing it here, sorry. See that little bit back and forth, so it can kind of hunt back and forth to help self-align. Self-alignment is good. Self-align the belt, and if that proves to be an issue, then we'll just shim it and it'll be fine. The brass washer or a Delrin washer, another Delrin washer, more Delrin. Huh? So anyway, we got no run out now, none of that. So we're just freaking dandy. So we're gonna call that done, or done as far as you're gonna see it. You'll see it later, and which is good. Over here, after the cleanup, we are all in. We didn't. It's not pinned in. Don't have a split pin on there yet, because we just kind of put this in for fit up, see how it's going, because this guy still has to, the crankshaft pulley still has to come out. See how that floppy that is? And I hope that's just the pin that's all beat up and wore and not the hole through the crank. But if it is, it really is kind of doesn't really matter, because the new one does not rely on this pin through the crank. I mean, it does, but it really doesn't completely, because the new pulley has a split in it with a grub screw that clamps that pulley onto the crank end. So it kind of doesn't matter too much. Anyway, we got the new spring in there, and as you can see, like, there is that small amount that they allow for in that new, that works just dandy. The new spring also shoots her right back out, so that's what you want. So we are good. I mean, this is all good to go. Probably put some grease on there, some oil on there or something. There is no you know what, maybe you don't want grease in there, because these would have been originally used in winter, and if you had grease in there, that would just stick in there. you'd never get that to draw back. So maybe just dry is the best way to go. So anyway, gonna end this video. On to the next thing, which is gonna be, the next thing is gonna be that dude, and the parts came in for the carburetor, the new needle and seat. So that's gonna be a bit of an undertaking. I mean, whatever, it's just something that's gotta be done. But the next deal there is we got to get that seat out, and that seat does not want to come out, so it may end up having to be drilled out. That dude over there, that's carburetor, make it happener, carbonator. So anyway, hope you guys are gonna have a good weekend, because it is now the weekend here. And oh yeah, I started to do that, and then the all the wiring has got to be addressed, and maybe we'll get a little bit of a coat of paint on that firewall. Anywho, guys, have a nice weekend, and we'll maybe catch you in another week.